Welcome to another informative series brought to you by Autruo. The last time we looked at function block diagram. The way this language is used during programming was discussed in detail. Finally, we ended off looking at the unique features this language has over the common programming language. In today's series we will be looking at Sequential Function Chart. The way this programming language is used will be discussed in detail, coupled with a practical example. Stay tuned. Sequential function chart is also another graphical way of programming PLC. This programming language is commonly used and easier to represent scenarios where there are multiple states of operations. This language is also similar to the flow charts of a computer science algorithms. However, unlike the other graphical programming languages, sequential function chart programming is done in two specific formats, which are steps and transitions. Step depicts what is happening as per the program requirements, while transitions are the conditions for the next step. Now let's look at a typical work example. In our case, we have a conveyor system that moves products from one of the conveyor to the other end of the conveyor. Now the plan is to monitor the product moving from point A to point B. In the same vein, we also intend to monitor our conveyor as well. Now let's make it sync. We will create our tag accordingly. We will define our input and output conditions accordingly. Now we will start defining our steps accordingly. The first one, which is S1, depicts a ready system, which means when the press or push button, the conveyor system will be on standby, and it is only when the conditions are met that the conveyor should start rotating. The next step is the system, followed by a quality check. Now in this step, the plan is to have a sensor that checks bottles that does not conform with the required height. Why the last condition on this conveyor line is the rear conveyor, which is the adjacent conveyor. From here we'll move a step to the quality step. Now we will define the step as follows. The next step here is the discharge conveyor, follows closely by the bins. Now we want a situation where this process can repeat itself. We do not want a one-off program. Now we will click on the jump symbols up here. Now we will select S1. The plan to make the process should repeat all the steps again starting from S1. We define the bin as such too, but this time, we will be starting from S3. The next thing for us is to start defining our transitions. We only want the step to change when the start button is triggered. Now in the qualifier, we will choose N, which means the out should be active as long as possible, which is in this case system ready. In the second step, system ready is in series with a backup sensor. This means if the conveyor is full, the step will not switch. The qualifier will be tagged to N, and the action is to motor one of the first conveyor. At step 3, the condition of the transitions is the sensor that detects products at a height that is in series with the discharge backup sensor of the bin. As usual, the qualifier will be N and the action will be the height discharge motor, which is the motor that moves the unwanted bottle to the bin. At step 5, the plan is to prevent the conveyor from moving when the bin is filled. The transition will be tagged as normally closed. The discharge sensor, which is at the bin. So as soon as the bin is filled, it should switch. Now let's simulate our program. Now when I trigger the input conditions, the step will switch. This also comes with some additional features. The chart comes with input conditions like resets, stop, auto mode, manual mode, and the likes. All this feature comes naturally with this programming language. Let's trigger the stop bits. As you can see, the chart is no more active. Let's trigger the start button. The conditions are set, but there is a need to put the reset button. Now when I set the reset condition, the chart is now active. And also, when the input conditions are set. The step changes accordingly and it also starts automatically. Overall, Sequential Function Chart is a programming language that is easy to use and it comes with additional features that the other graphical programming languages don't have. Over to you, Andrea.
Perfect, Laura. This language is very easy to understand, because all the steps that happen during I/O manipulation can all be seen visually. So when the step is stuck at a particular step, the conditions can easily be looked at. And in our case here, we are considering the transitions, as you said. So the extra features come along with this language, which makes it a perfect fit for some installations.
Interesting. So no wonder why some machine has a spot for program reset. And there is also room for some manipulation, which is to put the machine either in manual mode or automatic mode.
Now let's do a quick recap. We started off by looking at what a sequential function chart is. The major difference between steps and transitions was discussed in detail. Finally, we ended off looking at its application in the conveyor system. In the coming series, we will be looking at text-based programming language. The way this language works will be discussed in detail, coupled with some practical examples. Hope you have learned something new today. See you in the next one.